Well, now we are ready to start our brief discussion on the form parameters. As we have discussed earlier, under form group of parameters, we have 4 controls. One is straightness, second is flatness, third one is circularity, and the fourth one is cylindricity. In this introductory module, we will speak about flatness parameter. Flatness is a 3-dimensional form control which specifies a tolerance zone of distance between 2 parallel planes within which the part surface must be contained. In other words, when we say the bottom surface of this part should be flat, the convexities or concavity or the ups and downs of available in this particular surface all should be contained within the stipulated value suggested in the drawing. That is the meaning of flatness. Let us try to understand better with an example. Look at this drawing where the thickness is dimensioned as 36.36 millimeters with a tolerance of 1 millimeter, that is in other words plus minus 0.5, and the top surface flatness control is indicated within 0.2 millimeter. What is the meaning? All the ups and downs, the high point as well as the low point should be contained within 2 planes of 0.2 part. Since the tolerance zone is distance between 2 planes, the tolerance zone is indicated in both the views, in the front elevation as well as in the side view. I have yet another example here wherein the size tolerance of a given part is 25 with 0.5 millimeter tolerance plus minus 0.25, and the top surface says flatness control within 0.1 millimeter. Now, if I have a part like this shown here, on one side the dimension is towards the lower limit 24.75, on the other side the dimension is towards the upper limit 25.25. Now, if I ask you a question, is this an acceptable part? What would be the answer? Is this part acceptable as per the given drawing, or is this part is a valid part? I would say as long as the undulations, ups and downs, waviness or concavity, convexity, etc., all on this surface are contained within 0.1 tolerance zone, this part would be an acceptable part. Having dimension on one end towards the lower limit, having dimension on the other side towards the upper limit indicates a taper available on your part, but a tapered surface can still be flat within 0.1. So, when I check for flatness control, the orientation we are not bothered. The plane can be oriented in any direction. It could be 5 degree, even a 45 degree plane can be a flat plane, right? So, since orientation is not controlled in flatness, this becomes an acceptable part. How can we measure the flatness in a given part? Supposing in the same example, I want to check and confirm the flatness of this bottom surface should be within 0.1 millimeter. How can I confirm that? There could be 2 or 3 different methods could be adopted. I can keep on a surface plate. Imagine the table surface as my surface plate. If I keep this part on a surface plate, and if I can look for the gaps by using a feeler gauge, then the feeler gauge which is entering the gap is a measure of flatness error available on this bottom surface. Because when I keep this part on the surface plate, since surface plate is a master, the part takes a natural seating of 3 highest points, and all the other points I can compare with respect to the plane of the surface plate. What else I can do? I can keep the part upside down on a screw jack, 3 leveling feet, nothing but 3 different screw jacks, and independently I can adjust each screw jack such that on top of the screw jack the dial indicator reads 00. That means I need to level the plate such that I have a theoretical plane on this top surface by having 0, 0, 0 at 3 farthest points. Once I do the leveling, then I can move the dial indicator throughout the part. Then the difference between the maximum and minimum reading of my dial indicator is my measure of flatness error. Well, is there any other method? The third method could be to use a surface plate having a hole at the center in order to receive a dial indicator upside down. If the surface plate is having a bore, I can keep the dial indicator upside down and I can have a direct reading on the required